Welcome dear students. In this video lecture we are going to solve the numerical which is asked in the question 1C part of 1st January 2022. So data given over here is a roof of electrically heated home is 6 meter long and 8 meter wide and 0.25 meter thick, is made of concrete layer whose thermal conductivity is 1.0 watt per meter Kelvin. The temperature of the inner and outer surface of the roof are measured to be 13 degree and 15 degree respectively for a period of 12 hours. Assume the steady state condition for the mentioned period of 12 hours. Determine the rate of heat loss through the roof, and second, the cost of heat loss to the homeowner if the cost of electricity is 0.5 per kWh. Students, let's write the given data and we prepare the schematics and then we solve the numerical. So given data, the length of roof is given, that is a 6 meter. The width of roof is given, that is 8 meter. The thickness of roof is given, that is 0.25 meter. The inner temperature and the outer temperature is given. The inside temperature is 30 degrees centigrades and the outside temperature is 15 degrees centigrades. The time period, that is a 12 hour, and the rate of electricity is given, that is 0.5 per kWh, as well as the thermal conductivity of the roof is given, that is 1.0 watt per meter Kelvin. It means, suppose we have the room like this as I shown over here in the schematic diagram. So this is the roof which is made of an concrete. So this kind of structure is there. This is a concrete material. This thickness is given, that is 0.25 meter. This width is given, that is a 6 meter. This is given as a 8 meter. So students, and second things mentioned over here is a steady state condition. So we can apply the equation for rate of heat transfer, that Q dot is equals to minus Ka dt by dx. Here the thermal conductivity is given to us, area we can be able to find it out, the temperature difference is given to us, the thickness is given. So using this equation of Fourier's law, we can able to find out the rate of heat loss. Area given over here, it is a 6 cross 8 meter, so it becomes a 48 meter square, and the temperatures are given, that is 30 and 15. So let me apply the equations. Q is equals to minus thermal conductivity is given, that is 1.0 watt per meter Kelvin. Area is 48 and the temperature difference is 30 minus 15, and the thickness of roof is given, that is 0.25. So finally we get the rate of heat loss is 2880 watt. So Q dot is 2880 watt. Now we need to calculate the total heat loss during the 12 hours. Amount of heat loss through the roof during the 12 hours. So we need to find it out using the equations, that Q dot into the time. So our answer for Q dot is 2880 and the time is 12 hours. So we get 34,560 watt hour, and if we want to convert this into the kilowatt, then it becomes a 34.56 kilowatt. So that is the total heat loss during the 12 hour. Now second one, that is the cost of this energy. So the cost is equals to the amount of energy multiplied with the unit cost. So here the amount of energy is 34.56 and the cost of unit is 0.5 rupees per kWh. So here we get 17.28 rupees. That is a cost of this heat loss to the owner. Thank you, students.